Establishing a human presence on Mars presents unprecedented opportunities and formidable challenges. The red planet's harsh environment, characterized by intense radiation, frigid temperatures, and a thin atmosphere, poses significant obstacles to human survival. Innovations in habitat construction, such as utilizing Martian dirt and rock for building materials, are under exploration to create sustainable living conditions. Moreover, the psychological effects of prolonged isolation and confinement necessitate comprehensive support systems. Despite these hurdles, the pursuit of Mars colonization is driven by the quest for scientific discovery, the potential for resource utilization, and the vision of becoming a multiplanetary species. Black holes, regions of space-time with gravity so intense that nothing can escape, can make amazing sounds as if they are singing. They emit gravitational waves, ripples in space-time, that oscillate at frequencies corresponding to musical notes. For instance, the merging of black holes can produce waves equivalent to a bass note 57 octaves below middle C, a pitch far beyond human hearing. At Saturn's North Pole lies a persistent hexagon-shaped storm, each side spanning roughly 14,500 kilometers, large enough to fit Earth within. Discovered by the Voyager missions in the 1980s, this geometric cloud pattern has baffled scientists. Recent data from the Cassini spacecraft suggest that differences in atmospheric speeds create this enduring hexagonal jet stream. Imagine compressing the mass of our sun into a sphere just 20 kilometers across. That's a neutron star. These remnants of supernova explosions are so dense that a sugar cube-sized amount of neutron star material would weigh about 1 billion tons on Earth. Their immense gravity warps space-time, and their rapid spins emit beams of radiation detectable across galaxies. Venus, shrouded in thick clouds of sulfuric acid, has a peculiar rotation. It takes about 243 Earth days to complete a single rotation on its axis, but only 225 Earth days to orbit the Sun. This means a day on Venus is longer than its year. Moreover, Venus rotates clockwise, opposite to most planets in our solar system, adding to its enigmatic nature. Space is a near-perfect vacuum, devoid of air, rendering it completely silent. Sound waves require a medium to travel, and in the emptiness of space, there's nothing to carry them. Astronauts communicate via radio waves, which, unlike sound waves, can traverse the void of space, allowing for communication despite the silence. Not all planets are tethered to stars. Rogue planets, also known as free-floating planets, drift through the galaxy unbound. Formed in protoplanetary disks, gravitational interactions can eject them into interstellar space. Detecting these dark wanderers is challenging, but gravitational microlensing has revealed their presence, suggesting they may be as numerous as stars in the Milky Way. Our moon is slowly drifting away from Earth at a rate of about 3.8 centimeters per year. This gradual separation affects Earth's tides and will, over millions of years, alter the length of our days. The moon's recession is due to tidal interactions, transferring Earth's rotational energy to the moon's orbital energy, causing it to spiral outward. Ceres, the largest object in the asteroid belt between Mars and Jupiter, is classified as a dwarf planet. Recent studies suggest that beneath its icy crust lies a briny ocean. NASA's Dawn mission revealed bright spots in Ceres' Acator crater, identified as sodium carbonate deposits, indicating that liquid water once existed beneath the surface and may still be present today. Deep within the ice giants Neptune and Uranus, extreme pressures and temperatures may compress carbon into solid diamonds, causing diamond rain. Laboratory experiments simulating these conditions have produced diamond formation, supporting this theory. These sparkling precipitations could form vast diamond layers around the planet's cores. Jupiter's Great Red Spot, a colossal storm larger than Earth, has raged for centuries. However, observations show it's been shrinking over the past 150 years. Once spanning 40,000 kilometers, it's now about 16,000 kilometers wide. The reasons for this contraction remain unclear, but it continues to captivate astronomers. A NASA spacesuit, known as the Extravehicular Mobility Unit, or EMU, costs about $12 million. Designed to protect astronauts from the harsh environment of space, it provides life support, temperature regulation, and mobility. The high cost reflects the advanced technology and materials required to ensure astronaut safety during spacewalks. Mars is home to Olympus Mons, the tallest volcano in the solar system, standing about 22 kilometers high, nearly 3 times the height of Mount Everest. Its base spans 600 kilometers, roughly the size of Arizona. Olympus Mons' colossal size is attributed to Mars's low surface gravity and lack of plate tectonics, allowing lava flows to build up over time. Nebulae are vast clouds of gas and dust where new stars are born. The iconic pillars of creation in the Eagle Nebula showcase regions where dense gas clumps collapse under gravity to form protostars. These stellar nurseries are illuminated by the radiation from young, massive stars, creating breathtaking cosmic landscapes. In the constellation of Aquila, a massive cloud of gas and dust contains enough ethyl alcohol to fill 400 trillion pints of beer. While not suitable for consumption, this discovery highlights the complex organic chemistry occurring in space, offering clues about the building blocks of life. Stretching over 10 billion light-years, the Hercules Corona Borealis Great Wall is the largest known structure in the universe. This colossal galactic supercluster challenges our understanding of cosmology, as its immense scale seems to contradict the cosmological principle that matter should be evenly distributed on large scales. According to Einstein's theory of general relativity, time moves slower in stronger gravitational fields. Near a black hole, this effect, known as time dilation, becomes extreme. An observer far from the black hole would see time passing normally, while someone close to the event horizon would experience time at a much slower rate. In about 5 billion years, our sun will exhaust its hydrogen fuel and expand into a red giant, potentially engulfing Mercury, Venus, and possibly Earth. This expansion will cause the sun's outer layers to drift into space, forming a planetary nebula. The remaining core will contract into a white dwarf, a dense, Earth-sized remnant that will gradually cool and fade over billions of years. This transformation is a natural part of stellar evolution for sun-like stars, marking the final stages of our sun's life cycle. Space is full of wonders, and we've barely scratched the surface. Which fact blew your mind the most? Let us know in the comments. Don't forget to like, subscribe, and turn on notifications so you never miss an adventure into the unknown. Until next time, keep reaching for the stars.